Hi everyone, welcome back to another wonderful math video. Today we're going to be talking about the Pythagorean Theorem. Yum, yum, yum. As you hopefully know, or maybe not, in any right triangle, meaning a triangle with a 90-degree angle, the two sides that are opposite, not opposite the 90-degree angle are called legs, and the side opposite the 90-degree angle is called the hypotenuse, and we call that C. So any of the other two sides, you square their lengths, and you add them up, and that's supposed to equal the square of the length of the third side. So maybe a visual will help, and here's kind of what we're working on here, number one. And here, my A is going to be 5, so that's going to make it 5 squared. And my B is going to be 12, so I labeled those in blue so you can see them on the side of the triangle. 5 squared plus 12 squared, and that's going to equal C squared, which is the hypotenuse squared. It's just that third side. You know, we use the letter C, but it doesn't have to be C, but that's what we use. And so that's the relationship, and that's what you want to set up. 5 squared plus 12 squared equals C squared. Then we have to simplify. So that means that 5 squared becomes 5 times 5, because squared just means multiply by that number by itself. And same thing with 12 squared. That's going to be 12 times 12. And so that's going to equal C squared. Just leave the C squared alone. We're not going to worry about that until we have the blue part just be one number. So let's keep simplifying the left side. 5 times 5 is 25, and 12 times 12 is 144. And again, we're just going to leave that C squared there. Then you add those together, and you get 169, and that's still going to equal C squared. Now what? Well, we got to get C by itself. So in order to get C by itself, we have to square root, because square root undoes squares. It's the opposite of squaring. And so if we square root a square, we get that C squared to be back to a C. So we're going to square root both sides, and that's going to give us that C equals 13. Hooray! And we have solved the problem. So we have found the missing side. Well done. Let's do another one. This one here looks very similar. Please pause, if you will, and try to figure it out yourself. But we're going to set this one up as well with the blue parts. So 12 squared plus B squared. I just decided to call that unknown side B. Notice that it's not C, though, because C is the hypotenuse, which in this case is 13. So that 13 goes in the place of C squared. Then we can simplify that. And so 12 squared becomes 12 times 12 plus B squared, and that equals 13 times 13. Which is 13 squared, of course. And then we simplified 12 times 12, that's 144. And that's going to equal 169. Then we subtract 144 from both sides, so that the reason why is so we want to get that B squared by itself. Because eventually we want to square root both sides. So we get that there, and so we subtract 144. And then on the left side, we're just left with B squared and nothing else on the left side. And the right side is going to be 25. Now what? Well, we got to get B by itself. And since it's a square, we have to undo the square. So that means we have to square root both sides. So we're going to square root the left side, and we're going to square root the right side. And that's going to give us that B equals 5. And you know what? We're done. That's it. Just put that there. We know that B equals 5. How about that? Hope that was helpful. Let's do another one. We've done ones with whole numbers. You know what? Let's try one with a decimal. That doesn't give us a whole number. Let's try number 6. Well, maybe I can zoom in just a little bit. Let's see here. So, number 6. Well, notice how we have the and feel free to pause the video and work this out on your own. And we're back. And so the blue parts are A and 1. Again, I could have used B. I could have used A. It doesn't matter. A and B are interchangeable. The important part is that I know that the hypotenuse is C, and that's that 2 there for us, because it's opposite the 90-degree angle, which I marked in purple. So that means that we take the blue parts and we square each one, and we add them together. So A squared plus 1 squared equals 2 squared. And that means that if we simplify that, that means A squared plus 1, because 1 squared is just 1, equals 4. Then we got to subtract 1 on both sides. The reason why we do that is because we're trying to get the a squared by itself. So we subtract 1 from both sides. We put a little line so that we know that we're going to subtract that. And that on the left side, we're just left with a squared. And on the left side, you can see 4 minus 1. That's just going to be 3. Now what? Well, as before, we got to get that variable by itself. We got to get that a by itself. And because it's being squared and we want to get rid of the squared, we got to do the opposite of squaring, which is square rooting. So we're going to square root both sides, and that's going to give us a equals the square root of 3. Now, I'm usually okay with that. You can leave it as square root of 3, but this particular assignment and also some of the questions on this, on the rest of the assignment and on the test, ask for a decimalization. So at this point, you can just put that in your calculator and push the square root button. And what that will give you is it'll give you a nice decimal, which is about 1.73. Actually, the decimals go on forever and ever without repeating. But we're not going to put all those decimals because that would be impossible. So instead, we're just going to round off at those those 2 decimals there. So 1.73 is going to be good enough for us. So that's actually our answer, which means that a is 1.73, and we are done. And that's how you do these triangles. That's how you find missing sides using the Pythagorean theorem. I hope that was helpful. Please give me a like, share, or subscribe. Thank you. Buy my merch.